Hello and welcome back to the Alteryx Weekly Challenge from me, Nick Bignell. This is challenge number 103, just another game. So this is about predicting the Super Bowl scores. So we're looking at, we're looking at the New England Patriots 2016 and 2017 seasons and attempting to use a model. In this case, they're suggesting use linear regression model to work out the variable TM, which is the score, which indicates the number of points the Patriots scored, with the two Super Bowls and also for two games in the season. So if we have a look at the start file, what we have is some data that needs sorting. It's in a particularly bad format that needs to be looked at. We then have some, so that's for two different years, 2016 and 2017. And then what we've got to try and find is for the Super Bowl week, we've got the actual scores, points scored. So there's 33 and 34, and then the predicted score from the model. So if we go back to, so this should be 34 actual score for the Super Bowl. So it doesn't give the date, or maybe it's this one's 34. Oh yes. Okay, 2016 was 34. Okay, that's interesting because that doesn't give you a year. Okay, alright. And neither does this one. Okay. So is there a year? So we got a date. Sunday, October 9th at 1:02 p.m. Interesting, but no actual year. Okay. Right, first thing I think we need to do is sort out this data. We seem to have two rows of headers in rows 1 and rows 2, and then the actual data starts in 3. Okay, let's split this out and see what we've got. Yeah. So if we bring in a pass, we'll do it on let's do it on the 17 data first. Okay, so we'll pass it on commas. How many have we got? I can't see. No idea. Alright, okay, let's just add loads and see what we get. Okay, run that. Okay, so we've got 1, 2, 3, 4, 5. Okay, we've got some more to go. 1, 2, 3, 4. Okay, we've got a few more to go. Okay, hopefully that will give us enough columns to be able to work it out. Oh, one too many looks of it. Okay, so we go 25. And then we've got them all. Here's the TM. This is the score we're looking to use as the target in the model. All the rest of it we don't need, but week has got the week. Now she says, well, we'll take week 13 as well, I guess. It's week 13 and try and predict that, and then the Super Bowl one down here. Okay, so let's sort this data out. I think first thing, let's get rid of the data we don't need. So, it's not nice, is it? Okay, hang on, let's get rid of the first field and then the first column, the first row even, and then we can use this one to create a title. We don't need field 1, 2, 3, 4, 5, 6. Probably don't need any of that. 10, and then score starts at 11. Okay, right. So from that one and then 1 to 10, we don't need. Let's get rid of those. They're all strings, right? They're all strings, so we'll have to turn those numbers into. We'll have to turn them into numbers at some point. So remember that. Okay, and then we get rid of this. Just skip the first row. So skip first row. Okay, and then that will give us the ability to then use the second row as the dynamic rename. So the name of the field. So if we do this and then put that in, take first name, I can run that. that should give us, what was the error message there? Multiple fields named 2. Okay, got multiple fields in there. Yeah, quite a few. Oh yeah, that's right. We will have. Don't think it matters particularly. If we cared about whether the defense and offense, because this was offense I think and this was defense, so then maybe it'll matter, but I don't think it matters. Okay, we've got some gaps in here, so let's get rid of the gaps. So where TM equals 0 we want to get rid of. Okay, predictive, and we want to get filter. We can just do where TM does not equal, oh, is not empty. Okay, right, that should clean that up a bit. Now we have some data to work on. Right. Alright, so that would be the we can stick a formula and then we still have a year at the end, I think. So we'll create a year, and this one is 17. Okay, and I think we probably, hold on, before we do that, we probably want to autofill this just so we can sort those out. So we look at the metadata, yeah, bytes, string by integer, double, right, perfect. Okay, and then we can I'm going to copy all of this, paste it for 2016. Okay, and then we'll change this at the end to say 2016, so at least we know what year it is. Alright, and then we just bring that all together, because it says in the things use both, let's say use both seasons as part of your data set or your training data. Okay, so if we therefore then, now we need to take out the ones that we're trying to predict, because we don't want them in the actual predicted data. So equals 13. Okay, let's just custom that. See what it is. DM equals 13, or yeah. Isn't it a? Oh, it's got a string. It's a string, isn't it? Or TM equals, and we want to, is it Super Bowl? Okay, so that should, why isn't it like that? What's it think this field is? TM is a byte. Okay, no, we don't want TM as a byte. No, we do. It's not TM we're looking for, it's week. What a numpty. Okay, alright. Yeah, that's that one there. Yeah, okay, that's better. Right. Alright, so that should give us, okay, so on this side we now, if we look at the data, yeah, we've just got those four with the year. Okay, so that means we can work off the other ones. Now we could look at the linear regression module here, but when we have the new fancy machine learning tools or assisted modeling, let's use them. So off the false side, which has all the training data, you can run this. So first of all, you press run. This will give us this will, I don't know, energize the modeling and kickstart it. So hopefully that will give us something to work with. Okay, so first thing you do now is start assisted modeling. Okay, so we have this starting tutorial page. Do not show the tutorial. It basically takes you through. Anyway, let's just get started. Okay, so available targets. So what we want to target is TM. Okay, and it's suggesting a regression. Use a regression when you want to predict a number outcome where the prediction outcome could be any value, right? So that's quite clear. We want to predict the score, so let's just click on next. Okay, yes, we want to proceed with this. All right, okay, so then it's saying these are IDs, so I don't know what rec is, but they'll be dropped, but then we have all of these other values in the to take from the model, right? So it's numeric, it's recommending all of them, so let's have a look at that. Right, the data set has no missing null data or null values. That's because we cleaned it up beforehand. Right, okay, so it's suggesting we don't need to use highly associated with target. Okay, that's fine. Weak association. Yeah, well, you know. Okay, well let's do next and see what we get. And it's suggesting, actually, here's linear regression, which is what was suggested in the challenge, but it's also suggesting a decision tree or a random forest. Well, let's just run all three, see what we get. Okay, so actually it's come out saying that random forest is the best model. It's got this little symbol here. You might not be able to see that. Yeah, the little green. So it's suggesting that one's the best one. So I think we'll pick that one. Oh, I'll pick all three. Let's do that. Okay, there's no reason why we can't have all three, and to see which one gives us the best result, or closest to the actual score, maybe. Okay, here we go. So if we go along here, you can see we've got an error there. Let's just it's a bit wider so we can see what we're doing. So it's created 3 random forest, linear regression, decision tree. Okay, so this is saying target must be selected in the assisted modeling tool. This is the assisted modeling tool. Okay, let's just make this a bit wider so we can see. Now I think you have to, oh, here we go, in the expert. Don't know why that's in there. Let's try that, see if that makes a difference. Ah, there we go, right, okay. And then in here, what's it saying? Missing connection. Okay, so let's bring in the true value. I think we can bring it in for all of them. Why not? And that should give us something to work on. So then we bring in a browse at the end on each one, and then we run it. Okay, there we go. Right, so let's have a look at the results. So we've got the results spread out like this, and maybe we just want to, well, let's go with this. So we've got year 17 at 2017 at the top, 13 and Super Bowl. It's saying 28 for year 17 and 29 for the and if you look over here, it was the actual number was 23 rather than 28 and 26, but for the Super Bowl in 2017 it's only a little bit out for the first 2017, but 29 versus 34. Okay, so let's have a look at the linear regression. That was the random forest we were looking at. So 23 versus 28, 33 versus 29, 26 versus 28, 34 versus 29, and then the last one, the decision tree. That looks like, well, quite close on the 2016 Super Bowl, but the rest are kind of out. So interesting. There you go. 3 different models giving these two are fairly close, I think, in terms of their prediction. But there you go. You can tweak them, I guess, and when you're in here, you can select different features. Here we can drop items that we may think are, too highly associated or not. We can increase the size so we can see all of them. Yeah, there you go. Thank you very much for watching. See you again next time.